Now this last method, which is called the Cramers rule, happens to be the most complicated method, but it also is pretty efficient if your numbers are really ugly. So if your numbers are like decimal, so suppose you have like 3.1 times x plus 4.5 y equals to 4.92, something like this. If it's really ugly like that, then this method called Cramers rule is efficient. Okay, in order to learn this Cramers rule, you have to know something called a determinant. What's a determinant? Well, if you're given a table of numbers 2 by 2, so you have like one number here, another number here, another number here, and another number here. So you have, let's say you have 4 numbers. Then the determinant of this table is defined as A times D, diagonally, minus the anti-diagonal B times C subtracted. So one easy way to remember this formula is to just draw a ribbon, half ribbon like that. So it's like A times D minus B times C. So that's called the determinant of a 2 by 2 matrix. And of course there's a determinant for 3 by 3, 4 by 4. Every time you have a square table of numbers, then there is something called a determinant. But since for linear optimization we only have 2 variables, and 2 variables only create the Cramers rule with just 2 by 2 table of numbers, this is all you have to know. Okay, now in order to write down the Cramers rule, first you need to know how to change the equation into table of numbers. And the way you make the table of numbers from system of equations is first make sure that everything is in the form of something times x plus something times y equals to a number. In a lot of cases they are already in that form, right? See, 1 times x plus 4 times y equals to 48. So this one is indeed in that form. This second one also is in this form. So first make sure that it's in this form, and then what you do is you just write down all the coefficients. This is 1 times x, so you put 1, 4, and then 48, and then 3x, 3, 4, 64. That's 3, 4, 64. And people could sometimes put a parenthesis over it, or it doesn't matter. Just put these 6 numbers, and often it's helpful to have this dotted line right here, or just a straight line, to remember that there's an equal sign in between. Okay, so once you have this matrix form, then there are many methods that make use of this form to find the solution. And Cramer's rule is just one of them. There are other methods called Gauss elimination method. And there's also the Gauss-Jordan elimination, which if you learn Gauss elimination, you'll naturally be led to the other method called Gauss-Jordan. I think it's just too much, so this one we'll never touch. But if you are really curious to know, just look up some Google videos on Gauss elimination. There are some very good ones. You can learn from them. Okay, so how do you use Cramer's rule? Well, for Cramer's rule to work, you should have a calculator. We're assuming that we have a calculator. Often the numbers become really big or very complicated. We need a calculator. So suppose you have the calculator and you can easily compute this determinant AD minus BC. Then whenever you have a system of equations like this and you're given this table, then let's say you have A, B, C, D as your coefficients, like 1, 4, 3, 4 here, and then you have M and N in the other side of the equality. If this is the form of your equation, then first x is computed by, denominator will be this ABCD, same thing. But in the numerator, you take this MN and replace the first column AC and write MN and then BD. And taking the ratio of these two numbers, remember these are numbers, right? Because you're calculating this. Taking the ratio of these two numbers gives you the value of x. In the same way, y, the denominator is still the same, but this time instead of mn replacing the first column, this one replaces the second column. So it's AC is the same, but mn replaces the second column. So that's the formula. Now, because we only just have a formula, it's probably hard for you to understand how it actually works. So let's try to work with this example here. So it says, well, we need the A, B, C, D for anything, both of the x and y. So let's calculate that first. We'll calculate 1, 4, 3, 4. And this is this 1 times 4 minus 4 times 3. So that's 4 minus 12, which is negative 8. Okay. Now for x, you need to replace 4864 with the first one. It's 4864 with, so this thing replaces the first column, and therefore you should be writing 4 here. Let's find the determinant, and this will be 48 times 4 minus 64 times 4. And my calculator says that's negative 64. I actually had to use a calculator to compute this. Okay, and then you have 1, 3, and then 4864 replaces the second column. And if you calculate that, 1 times 64 minus 48 times 3, that will give you negative 80. So what is x? X would be this thing, negative 64, because that's this matrix determinant, and divided by negative 8, so that gives you positive 8. And then for y, you take this number, negative 80, and divide by this same thing, negative 8, so you get 10, and that's how you get 8 comma 10 as your x and y. Alright, so let's try the second one, see if it gets any easier. So what do you do again? You put 3, 4, 4, 2 as your coefficient of the left side, and there's a 64 and 62 for the other side, the constant terms. So we need first the 3, 4, 4, 2's determinant, which is 3 times 2 is 6, 4 times 4 is 16. You subtract them, you get negative 10. And then let the 64, 62 replace the 3 and 4, so you get 64, 62, 4, 2, and then you do, let's see, do this. It's 64 times 2 minus 64 times 2 minus 62 times 4. Let's see, that's 128 minus 248, so that is negative 24. Yeah, so it's better to do 248 minus 128. I'm just too lazy to use a calculator. Alright, so it's negative 120. Okay, so that means x is the fraction of these two. It's negative 120 divided by negative 10, so you get 12. Alright, then the next one is 3, 4. Then you replace the second column by 64 and 62. So that means 3 times 62 is 186 minus 64 times 4, 256. So let's see, 186 subtracted, that would mean 0, and then 7 with the minus sign. Okay, with a minus sign, minus 70 is what you have. So y would be negative 70 divided by negative 10. It's this determinant divided by this determinant, so you get 7. So the answer for this would be 12 comma 7, with x and y being each 12 and 7. So that's how you solve system by Cramer's rule. It looks really complicated, but if your number is like really bad, then this will turn out to be the best method to use.